All right, everybody. Well, it's 10 o'clock. We're going to go ahead and get started. Hello, everyone. My name is Bobby Henderson. I'm a sales engineer here with Long in our hydronics, plumbing, and steam group. Today, we're going to be talking about a topic I'm super interested in. So system sizing tools for gas, electric, and heat pump water heating. So we're going to go through. Today's just going to really be a conversation in two parts. First, I'm going to show you one of the tools that we use all the time, but you can use as well. It's in the public domain. It's one of PVI's sizing tools that they have on their website. So I'm going to walk you through that a little bit. And then on the second half of our conversation, I'm going to kind of show you quickly an overview of how we're sizing heat pump water heating systems. I know that's kind of a hot topic for everybody right now. So I'm going to give you a quick overview of that. So, like I said, topic number one. So PVI 3 or 4 years ago came out with this, they call it their OptiSize water heating program. You can use it online or on Android or Apple. They've got the app for it. So I'm just going to walk you through it real quick. So we're going to go to the PVI website, pvi.com. So on PVI's website, we're going to go to their resource tab. On the resource tab, we're going to go to their OptiSize water heater sizing program, the link right here. You can see below they have a PVI sizing guide. What that is, that's actually their old program that's still in function. Some people might still use that, but this is their newer water heater sizing that I'm going to walk you through. Okay, so we're going to click on that. It's going to take us to the OptiSize water heating program. Okay, so let's get started. So the first thing it's going to have us do is select our facility type. And I like this program because it's really graphical and really intuitive and very quick. So for today's example, maybe something a lot of us are selecting these days, but we're going to pick an apartment or condo. We're going to go to next. And the next tab, it's going to take us through our fixture count. So for today's example, we have a 150 unit apartment complex. And in that apartment complex, I have 51 bathroom units and I have 100 2-bathroom units. So my total private lavs are 250. I'm not going to count any public lavatories. I'm going to have 250 showers and shower tub combinations, assuming that's what we're using. Let's see, I have some other options here, but again, I have 150 units, so I'm going to have 150 kitchen sinks. I'm going to have presumably 150 clothes washers and 150 dishwashers. And we'll add in 2 janitor jobs as well. Now you can see below here, if let's say you had some other things you wanted to add, you could put in a custom fixture with a flow rate. Okay, so that's going to take me to my next tab called their system tuning tab. So what this is here is we've got some more inputs we can work with. So we can add what our cold water temp coming in from the city is. We can put our stored water temp. Usually we're storing at 140 these days, but that's we can change. We can make assumptions for efficiency based on if we're using high efficiency product, what have you. It defaults to 97%, which most of PVI's high efficiency product is. And now the next input we're going to go to is our input. So this is really built, this tool is really built for all their high efficiency gas water heaters. So here's where I get to go in. And so we're not going to go through all of PVI's equipment that they sell here, because this is just a topic of system sizing. But you can see here, we can drop down and we can look at all the different inputs, anywhere from 199,000 BTUs up to 1.6 million. Again, this is really for their high efficiency water heating equipment that we're using in most installations. So in this case, I might start with, say, a 700,000 BTU. I know I have a 700,000 BTU Conquest unit. That has a standard storage size of 130 gallons. I'm going to go down here to my system demand and supply graphical representation. And what this is showing me, and this is kind of nice because it's a graphical representation, it's saying, wait, that's going to be way too aggressive for our demand. So we're showing 700,000 BTUs. we're going to need a lot more water heater than that. Well, how much do I need? Well, I can actually jump down here, and they've got some nice outputs here. This is showing our dynamic demand. And what this is this is a, they're going to use their ASHRAE tables based on the fixture counts that we just put in. And we're going to come up with a dynamic demand. This might be how much water is flowing at any one time. Well, what we do here is based on that apartment complex, or let's say it's a K through 12 or university or something like that. Every 15 minutes, they're going to look at every 15 minutes. What are we using? Actually, it's really a minute by minute, and these are 15-minute intervals for the course of 2 hours. So we're going to look at our demand over the course of every 15 minutes for 2 hours. And that's going to show us a minute by minute where we are with our storage and our demand. So that number is really referring to that. And what this spits out is they're saying, hey, maybe our input output, and I'm going to look really at our input here, should be about 1.4 million. Well, let's start with maybe 2 of our 700,000 BTU units. Well, okay, well, we're still a little bit short. And what now we're seeing our tank supply in the line graph, and then we're actually seeing our demand down low. And what we're seeing is we actually run out of water during certain periods of flow. So you can actually see on the right here, we're showing a tank showing our usable storage at any one time. So what I'm going to do is I'm probably going to bump up my input to 800,000 BTUs. Nope, 2 800,000 BTU units are still not going to get it done. So I might just keep going. I'm looking at 2 900,000 BTU units. Oh, it says I'm going to make it, but I'm still really, really aggressive. Okay, maybe let's go to 2 million BTU units. Okay, now we're getting a little bit closer right here, and it looks like we're not going to run out of hot water. So now we look, okay, we've got our input, we've got enough input. And what I like over here is we're showing, okay, we've got 70% redundancy. So what it's saying is if we were to lose one water heater, we'd still be able to meet 70% of our load with a single one of these other water heaters. Lastly, I want to show down here, this is what I'm using is 2 million BTUs because I picked 1 million BTU units. Comparatively, if I were to do an instantaneous system, and remember, this is 2 130-gallon water heaters, comparatively, I would actually need to have 3.7 million BTUs worth of instantaneous water heaters. So I like this program a lot because it gives us a lot of flexibility. This is a really short overview. Definitely reach out to one of your long salespeople if you need some, more in-depth training on how to use this. We can also add in additional tanks, storage tanks. I'm not going to do that for this example. And we kind of get this nice little output right here. Okay, moving on. We're going to go back to our slide deck here. Heat pump water heater system sizing. Big topic lately. And everybody probably has a lot of questions on how we're sizing heat pump systems. So I'm going to move through this really quickly, but hopefully this is helpful. So maybe some of you have seen this. This is a piping diagram for a typical heat pump water heating system. Up here, we've got the heat pump water heater. This could be air source, this could be water source, or this could be wastewater source. We have different products that do various different types of sourced heat pump water heating. And then you usually have some sort of storage tanks. Storage tank 1, 2, you might have 3 or 4 storage tanks depending on the size of your system. And you're also going to have a swing tank here. Purpose of the swing tank is to have some backup, or is to have your recirculation load met by some resistance electric heat. Could also be gas heat depending on the type of system, but most of the time we're doing these heat pump water heaters these days to try to meet some electrification requirements. So real quick, while I'm here, what we're trying to do with our system, and this is for a single pass heat pump water heater, is we're trying to get our cold water. You can see our cold water makeup is going to be here. We're trying to keep our cold water here because this is where we're actually going to draw into our heat pump. We want the coldest water possible going into that heat pump for our best efficiency and best capacity. So that's going to flow all the way through, and it's in series between your storage tanks because we're charging this direction with our hot water, and then we're actually going to draw out the other direction when we have demand going through our swing tank and out to our building. Okay, let's just go through a quick example in a few minutes we have left. Okay, so I stole this from one of our manufacturers' sizing tools. But the first thing, of course, just like in the OptiSize program we just looked at, we're going to determine our facility type. In this case, we're doing apartments. And in this case, I'm going to choose, it's going to be 200 apartment units. We have the ability to go in and select this based on occupancy. Occupancy is usually pretty helpful. In this case, we're just saying the number of apartments. We have some other more sophisticated tools, but for today's example, we might just need to know the number of apartments. We're going to determine our domestic hot water circulation heat load loss. This may be something you as an engineer would do. We also have some tools. We could guess 100 watts per unit. But usually you're going to figure out this depending on your line losses coming back to your water heating system. And this is that swing tank volume. What we looked at on the previous screen, you've got a swing tank. Usually that's going to be something small, 120, 150 gallons with a small element in there. We're going to size that element based off of your heat loss in your domestic hot water recirculation loop. Okay, let's get to the meat of this. So your recommended heat pump water heater recovery, 400,000 BTUs. So where did we get that from? Well, this is all actually based on ASHRAE inputs, depending on your building type, apartments, K through 12, again, food service, office buildings, what have you. We're going to pull this number based on minute by minute calculations that we're using from ASHRAE on your domestic hot water use. So what it's saying is for a full day for 200 apartments, we need about 400,000 BTUs of heat pump water heating recovery. Okay, but that's also going to give us a storage output, and we'll get to that in just a second. Okay, so where am I going to get and here's an input on this particular calculator, minimum heat pump water heater recovery. Okay, so now in this example, I'm using an air source heat pump water heater. Well, we live in Colorado, Bobby, so we have very cold climate, right? Well, exactly. So over on the right, you're seeing how a single air source water heater or a couple air source water heaters are going to lose capacity between 85 degrees outside. And then as we drop in temperature, you're going to see depending on your refrigerant, depending on your piece of equipment, we're going to see our capacity drop to zero. Well, I'm going to go up here, and this is just a table representation of that graph. And what we're going to see is at 85 degrees outside, I have 350,000 BTUs, and at 15 degrees outside, I might only get 94,000 BTUs out here. So what I've decided in this system is, okay, I'm going to design to 15 degrees. I'm going to use 4 heat pump water heaters at 94,000 BTUs. That gives me 376,000 BTUs as my minimum recovery. Okay, well, what if we were designing to 0 degrees or even lower? We would need to make that up with some sort of electric resistance, something like that. Okay. All right, let's move on to our maximum heat pump water heater recovery. Well, my maximum heat pump water heater recovery, this is not, again, an input. This is the minimum amount of heat pump that's going to be running at any one time on the hottest day of the year. Well, my table maxes out at 85 degrees outside. And what it's saying is, and mind you, this is for a single stage compressor. So I have a single stage compressor in this case. And at any one time, I have 350,000 BTUs running on a warmest day. So what that means is if my heat pump kicks on, it's going to be running at 350,000 BTUs. I need to know that because I need to design my system and my storage tanks large enough so that even on the hottest day, when I have a draw, if I go back to the storage tank on the previous slide, I can run my heat pump for 15 minutes. So I'm not short cycling my compressor. So that's an input that we need to pull. 350,000 BTUs in this case. Okay, 40 degrees incoming water temperature. I want to store at 140 degrees, and I'm going to distribute through my mixing valve at 120 degrees. What's all that going to do? Well, that's going to give me an output here. We already decided we have 376,000 BTUs of heat pump. What that's going to give me is that's telling me that I need 550 gallons of running volume. I need 140 gallons. This is the amount I need under my aquastat. My aquastat sits right here in my first storage tank. I need 140 gallons of kind of coldish water down here that I can feed to my heat pump. for 15 minutes running at my full single heat pump load. My swing tank, this was based on my total storage capacity is 700 gallons. I might be able to accomplish that with 1 or 2 water heaters, or excuse me, storage tanks. My swing tank heating capacity, this was based on my recirc load demand of 27 kW. Could also be gas, we could convert that to gas. And then down here, based on our ASHRAE calculations, this is how much daily domestic hot water we're going to use for our apartment. And this is saying 1,000 gallons per hour peak demands. We also, depending on your manufacturer, they might also give you this fancy graphical representation, green line showing our heat pump, how that heat pump is operating all day. In this case, it's running just about 24 hours a day, which is good. And then we're going to show our hourly domestic hot water usage, again, based on our ASHRAE tables. And then this red line here is showing our storage tank. And that's actually just showing a depletion rate. And you can see we actually get here pretty close. We've optimized this pretty closely with 700 gallons of storage and 376,000 BTUs. Again, and I apologize, I'm running over by a couple minutes here. The key thing is here, we don't have to have 376,000 BTUs of heat pump. We could supplement that with some electric resistance. In fact, in Colorado, if we're doing an air source unit, we're probably going to have to, because most heat pump water heaters today, at least, are not going to be able to operate very efficiently or at all at our cold ambient temperatures. So that was very high level. I appreciate you hanging with me. We would love to walk through this with you and your firm when you're sizing these systems. We can walk you through our tools. We can walk you through our methodology. There is a lot to take into place, and there is a big disparity between how we size these heat pump systems, because cost, of course, we know is a huge deal. Please reach out to us. We can walk you through the pros and cons of smaller systems, larger systems, different refrigerants, different sources. So, all right, guys, I know that was fast. Please reach out to your Long salesperson if you have questions on anything we talked about today. Thank you. Next week, join us for Atmosair. They're going to talk about indoor air quality monitoring. Thank you, everybody. Have a great day.